Yeah, so the idea here now is once we have this information about the normal distribution, what are we trying to do? Well, we're trying to find the probability that the percentage of people in this sample is going to be less than or more than this amount. Now we know the sample proportion is 19 or 89, but the idea with these sampling distributions is like, okay, when you take lots of samples, you may get different kinds of results, right? So we want to know the probability that the percentage of people with asthma is less than 10% when we take this sample. That's the idea with these samples. Right? You can sometimes get different results, but the more and more you take, the more accurate it's going to be. But we can actually determine, like this is how they determine the margin of error. Remember how we looked back at that example where there was like a margin of error with the polling results, right? This is kind of how they determined that. So how can we work this out? Well, it's going to be related to the z-scores, right? Because less than 10%, if we know that our mean is going to be like 21%, right? If this is 21%, then we want to think, okay, how many standard deviations away is that from the mean, right? And we had a formula to do that. Again, most of you kind of could do that logically, but if you want to think about how many standard deviations away this is going to be, how can you kind of work that out, right? Well, we want to think about, for example, what's the score that we're looking at? Well, the score is 10%, right? So 10% is somewhere. And what is the standard deviation? It's 0.04. So it's like 4, yeah, it's like 4%, right? So it's going to be probably, how many standard deviations away would that be? Roughly 2 point something? 2.3? Well, let's find out. So the idea is we can take our, there was a formula for this. So you could take, for the z-score, it was x minus the average divided by the standard deviation, right? So the idea is like how many standard deviations fit. X is the score that you're looking at. So 10%, right? So 10% might be roughly here or something, yeah? So the idea is like how many standard deviations away it is. In order to do that, we need to, just do that division, right? So what is it, 0.1 minus mu minus 0.21 divided by the standard deviation, which was this one, 0.04317. That's going to give us a z-score, right? Because that's how many standard deviations away it is. It's probably going to be a negative number as well because we're going to the left side. Right? What did you get?
Negative 2.548.
So negative 2.55, we'll round there. And then, what I haven't shown you, I don't know if I've shown you, have I shown you this table before? No. Okay, so this table, what this table does is, for a normal distribution, I showed you some certain percentages, right? The percentages were like, remember, within one standard deviation of a normal distribution, there was a certain percentage of values. It was 68%, right? So like there's a fair amount of the values here. But what this table does, it gives you the cumulative total, so the running total of how many people up until that particular z-score, right? So we know that this z-score is negative 2.55, so it's like here, right? So that's negative 2.55. And then if you go to your table and you go to negative 2.55, it's going to give you all the values up until this point. So it's probably the percentage of people is less than 10%. So it's going to give you your answer, essentially, right? So how you read this table is you can see that along here we have the kind of first 2 digits of the z-score. And then what do you have along here? You have the third decimal, right? Can you see that? Right, so you got the negative 2 point whatever they're looking for, but then there's the third decimal as well along this grid. So we want negative 2.55. So I'm going to go negative 2.5, and then we're going to go all the way across to here. And it's a pretty small percentage, right? It's this value here, 0.0054. Good question. No. So they have to give you, and I'll show you an example, they have to give you a table to calculate these. The FX100AU calculator can actually do some of these. Now that's not required.
So what you're saying is calculator?
Yeah, your peasant calculators. Now, these aren't required, right? Because they will give you a table to do it, but I'll show you why it might be helpful to have this, right? So anyway, the answer for this one, less than 10%.
Are they necessarily approved?
Say that again?
They're necessarily approved, like can we take 1 to
Are they necessary to prove?
Yeah, those approved.
These are necessary proof, yeah. So was it 0.0054? Right? Well, I don't know, Emily's got one, so she might be the only one who does well in this exam, because she... I'll finish quickly. More than 30% though. Now for more than 30%, again, what do we need to work out? First, we need to work out the standard deviation of that, so let's do that. Man, this is getting very messy. Blah, blah, blah.
Wait, didn't we have a first year history?
Then Emily can stay then. All right, so more than 30%. The Z-score would be, what's our score now for 30%?
What's our best score?
Yeah, so remember I had this formula here. You don't have to use that, but you can just think about it logically as well. So what am I thinking? Like here I had 0.1 before because it's 10%. So I want, for 30%, I want 0.3. Take away the mean still, which is 21%, 0.21, divided by the standard deviation. So how many standard deviations fit inside, essentially?
What do we get? 0.208. What? Did you say 0.20? I got 2.08.
I think 2.08 is right. It should be, if you think about it, right, like how many standard deviations away? It should be more than 1, because 0.3 is more than 0.04 away, right? So 2.08, is that what you got, James? Yeah. Yep. So this is how the Z-score now. How do we work out the percentage? Because first of all, what I'm calculating, 2.08, is over here, right? So 2.08. When I go to this table, what's it going to give me? The running total up until when? Up until this point, right? Can you see that? Right, so what area is that on this graph?
What?
If I get the running total up until this value. Everything that way. But what do I actually want? Sorry?
So you want the other bit?
I want the other side, right, yeah. So I want all this side here, right? So the idea is that sometimes you have to look at the question carefully. They may do things a bit differently. So if you want more than 30%, so more than 30%, we can use the value, but we're going to have to do something with it in a second. So if we want more than, let's go to 2.08. So scroll down here. So we want 2.0. So that's on this row. Over here. So 2.0, and then we want to go to the 8th one across. Oh man. Oh man. Oh man. 2.08, 2.0. There we go. That looks right. 0.9812. But what do I have to do with that value, you reckon?
1 minus that.
The 1 minus that, because the area under this whole curve is 1. We know that from our density function properties. And you're going to get 0.0018.
Wait, 10.
0.10?
Wait, did we find up to 30?
Yep, and then we did 1 minus that. Yeah.
0.018.
188? Yeah. So the idea is, like, what is that? That's actually like roughly 1.88%. So it's like, what's the chance you get more than 30% in this sample? Less than 1%, like around 1%, or less than 2%, right? So the idea is like the margin for error seems pretty okay, right? So the idea is this is calculating the margins of error, right? Because you know if this sample is accurate enough that the actual representation is 21%, what's the chance you end up getting 30% in your sample? Well, it's a very small percentage. So we know that this is quite an accurate kind of sample proportion. Right. So that's the idea. Like it's working out how accurate these sort of samples that you're taking are. Okay. Now that's sample proportions.